Alumina corundum square tube, a high-purity aluminum oxide ceramic tube with a square outer cross-section and a square inner bore. Unlike round tubes, every surface is a flat plane, and every bore wall meets the next at a right angle. Made from 99% to 99.7% alumina. These tubes operate continuously up to 1,700 degrees Celsius and deliver the same chemical inertness and dielectric strength as standard round alumina tubes, but in a geometry that solves problems round tubes physically cannot. Four properties make the square geometry effective. First, density of 3.92 grams per cubic centimeter with zero open porosity, the same gas-tight structure as round alumina. Second, volume resistivity exceeding 10 to the 14th ohm centimeters full electrical insulation across every flat wall. Third, flexural strength reaching 379 megapascals, the four right-angle walls reinforce each other against bending loads. And fourth, dimensional tolerance held to plus or minus 0.1 millimeters on both the outer profile and the bore, critical for the precision fit applications that follow. Here is the first thing a square tube does that a round tube cannot. When an electric heating element has a flat or square cross-section common in cartridge heaters, strip heaters, and many industrial heating elements, a round bore can only contact each face of the element along a single line. A square bore, with its four flat inner walls, contacts the heating element across the full surface of all four faces. The contact area is roughly 4 times greater. This delivers two real benefits in service. Heat transfers from the element into the ceramic and out to the workpiece evenly across the entire surface, eliminating the hot spots that line contact creates. And because the load is spread across full faces rather than concentrated at 4 contact lines, mechanical and thermal stress on the heating element drops significantly, extending its service life inside the alumina sleeve. The second thing a square tube does that a round tube cannot, it does not rotate. In any cylindrical mount, a round tube is free to spin around its own axis. For many applications, that does not matter. But for sensors with directional output, for thermocouple wires that must exit at a specific angle, for connectors that need a fixed orientation, or for components with surface markings that must face a particular direction, free rotation is a real problem. A square tube placed in a matching square socket cannot rotate. The 4 flat faces lock against the 4 walls of the fixture, holding the orientation exactly where it was installed every time across every unit in production. This eliminates the need for set screws, keyways, or anti-rotation pins that round tube assemblies require, simplifying fixture design and making installation faster and more repeatable. The third advantage of square geometry, packing density. When round tubes are stacked side by side, the curvature of each tube leaves a triangular gap between every adjacent pair. The effective packing density is about 78%, and the contact between tubes is just a single line. Square tubes share their flat side walls completely. Stacking is gap-free. The packing density approaches 100%, and each tube rests on flat surfaces, meaning it cannot roll out of position during installation or operation. This makes square tubes the practical choice for compact furnace integration, custom slot assemblies, structural insulation walls, and any application where multiple tubes need to be densely arranged in a fixed space without wasted volume.